This video is about using sliders in graphs. So just open up a graph page and we'll type in a function such as x squared minus a over x. The a is called a parameter and it changes the shape of the curve depending on the value you ascribe to it or assign to it. Now in this case here, we choose Menu, Actions, and then go down to Slider. So that's Menu, Actions, Insert Slider. These are the various settings that go with the slider. This one here is the variable that has been defined as the parameter in the equation. This is its value initially, its default value, and we'll change this minimum to -10. And the maximum we'll leave at 10. The step size will change to 0.1 so we can actually see it in detail. We'll choose a vertical slider, and there are additional settings further down. We'll change the display to fixed 3 decimal place accuracy. We'll minimize the size of the appearance of the slider. There's our slider unit. There's our curve. We'll just move it down there. And you'll notice that the curve here has another component over here. So let's just change some of the slider settings. The slider values. So here we're going to decrease them. You'll notice the minimum turning point in that graph, the local minimum, is descending towards the origin. Notice that as soon as a hits 0, this term disappears and you're just left with x squared. So we'll get a parabola at the origin as soon as a hits 0. And there it is. If we continue down, the minimum turning point slips across to the other side of the y-axis and rises up. Notice this section of the graph here moves along the x-axis. The x-intercept increases, needless to say, because as that a gets bigger, you end up with x cubed equal a, and so the x-intercept shifts away from the origin. So that's the situation with sliders. We can, of course, add features to it, such as if we go to an Analyze Graph and choose Minimum to get the coordinates of the minimum turning point there. We've now got that available, and we've certainly got many more decimal places than we need. And if we now choose the slider values for the A, you'll notice that the minimum turning point coordinates also change. Now this is an interesting one here with a equal to -2. If you differentiate this, of course, you get 2x plus a over x squared. And with a equal to -2, you end up with an exact value there for your x at the minimum turning point, an exact value of 1. So this is quite handy to have. If you wanted to do the intercept there, you could just go to Geometry, Points On, and we'll turn that point on just there. And you'll notice that it provides the x-intercept with the y value there, 0. And as we again shift the value of a, the x-intercept shifts, the coordinates shift, and the coordinates of the minimum turning point also shift. So you might like to review this or even try your own slider with a graph.